Greenhouse chemistry. Here we've got three natural food colours. We've got yellow, green and blue. If we look at the ingredients listed on the back, we can see that yellow contains curcumin, whilst the blue contains a spirulina concentrate. Now looking to the green, we can see that it contains a mixture of spirulina concentrate and curcumin. So it would be fair to assume that the yellow and the blue make the green. Well, let's have a look at these properties by putting some of the colours into water. Let's start with the spirulina extract for the blue. And we've got a nice blue colour there. Next, the yellow. From the curcumin. And finally, the green. Don't need quite so much of this one. So we've got three rather attractive natural colours. Of course, the question is, what happens if we mix the blue and the yellow? Well, if we take some of the blue and add to it the yellow, we do indeed get a green colour. Suspicion confirmed. Well, we might be tempted to analyse this further with chromatography, and we might start with some coffee filter paper that we've cut into a rectangle here, and standard technique to draw a pencil line 1 centimetre from the bottom of the paper, and we've got 3 samples, so we've placed 3 X's on the paper. Here's one that I prepared earlier with some of the blue colour, the spirulina extract there. You can see that it stains the paper rather well. Bit of a mistake there. Well, let's have a look at the spotting process at home in the greenhouse. On the tile here, we will just have to wipe the tile there. We've got some of the yellow colour spilt on. Now we can have a look at spotting. Well, first the yellow, and we can spot using a cocktail stick to get enough sample on. So a tiny little touch on the paper, don't let it run down. Might have to repeat that a couple of times so that you get a nice tight little spot of the yellow material. And this of course contains the curcumin. Next, we'll have a look at the green. And that one goes in the centre. Again, a nice small spot. We're not looking to get a big spot of the material. And now we've got our 3 samples there, blue, green and yellow. Well, we have of course got to let those dry, so here's one of blue, green and yellow prepared earlier, which is nice and dry. Here's our chromatography tank. We're going to be using a solvent of ethanol, water and acetone or propanone. So we start with 2 centimetres cubed of ethanol water mixture. and we're going to add to that 4 centimeters cubed of acetone in water. At home this is a nail polish remover. And there we go, 4 centimeters cubed of that. Let's give that solvent a little mix. There we go. And into that then we can now put our sample chromatogram ready to go. Here it is. And we can watch what happens. Try to keep it away from the wall of the container. Watch what happens at the beginning. So in it goes in one smooth movement, and we're looking to see what happens there as the solvent moves up to the line of the 3 samples. And you might be able to see that the sample on the right, the curcumin, is moved with the solvent. We've got some movement of the material for the green spot, the yellow particularly, but the blue, as of yet, shows no movement. We need to let this chromatogram run a little time, and we also need to place a lid on the material. With paper chromatography like this at home, the paper does tend to sink sometimes, so I'll just prop it up with a little splint there and put the lid on whilst we let that run. And when you carry out chromatography, you should let the solvent run most of the way up the chromatogram, in this case the paper. So we're looking for the solvent to run about 1 centimeter from the top of the paper. I haven't got a perfect run this time, and the solvent's not quite level because the chromatography tank isn't quite level there. Well, we could let that run, but let's take it out already because it illustrates what we in fact need to see. So we take the chromatogram out. You should be able to see that indeed the blue is more or less remaining at the baseline. The green, yellow in the green is streaking up, and the yellow from the curcumin, the yellow colour, is really riding high on the paper. Now you might not be convinced from the sample size that we've got there, but in fact we can have a look at that with the same solvent system with one done earlier. So again, a strong central band. Yellow, in fact, from the yellow one is almost disappeared, but also that's streaking, but the blue has almost disappeared. But in fact this is somewhat misleading because although it seems appropriate, you can in fact carry out paper chromatography on these materials, these natural colours, because of their constituency. So if we were to look at the structures of the materials, we would see that curcumin here, the yellow one, contains these double, single, double, single, double, single, double bonds, conjugated system. Our structure of the phycocyanins here on Wikipedia, this is a complex protein related structure, protein-like structure, and there's no way we can carry out paper chromatography on a material like that. So our chromatogram, with the blue colour rapidly disappearing down here for the spirulina, was never going to work, and that illustrates the problem with thinking you can carry out chromatography on something which is quite a difficult mixture.